Hi, welcome to Nomis Academy. This time we'll be dealing with trigonometry in continuation of where we stopped. Trigonometry. And this time we'll be dealing with trigonometric ratio. We'll be dealing with trigonometric ratio. Trigonometric ratio. So let's write that. Trigonometric ratio. Trigonometric ratio. I know once you hear the word trigonometry, you're already having problem in your head, but it's as simple as what you can simply learn. Let's start from the meaning of trigonometry. You see, trigonometry is a branch of mathematics that deals with the relationship between sides and angles of a right angle triangle or of even other triangles. Are we getting it now? So trigonometry is simply the branch of mathematics that deals with sides and angle. I mean the relationship between the side and the angle of triangles. Are we getting it now? So let's take some of this ratio one after the other. We have learned about right angle triangle, so we're going to begin with that. So this is a right angle triangle. So let's take this angle to be 45 degree. 45 degree. So definitely you know that this is 90 degree. So what are the sides of this triangle now? This is definitely the hypotenuse, right? Remember, the longest side is the hypotenuse. So now this side is the opposite because it's opposite this angle. Opposite. And now this side is the adjacent. So these are the parts of trigonometry. Now let us think about their ratio. About their ratio in terms of sine, cos, and tangent. Sine, cosine, and tangent. That is how we tell the ratio of trigonometry, or let me say trigonometric ratio. And this trigonometric ratio is simply telling us the relationship between an angle and the side of the triangle. So let's take the sine, cosine, and tangent ratio for the sides and the angle relationship of a right angled triangle. So having 45 degree to be the angle of this particular part, so I can tell that sine theta, this theta simply represents an angle. What an angle is. Remember that angle can be measured in the, for your level, let's say radians and degree. So let's take degree for this topic. So sine theta, here stands for angle. So sine theta, to tell the relationship of this theta and the sides of triangle, the ratio is opposite over hypotenuse. Over hypotenuse. That is sine theta. Theta. So that is cosine theta of any angle is equal to adjacent all over hypotenuse. So adjacent all over hypotenuse. So why the tan theta is equal to opposite all over adjacent. So when you look at this three, you will see that every side comes 2 times, right? Hypotenuse came 2 times, opposite times, and adjacent also came 2 times. So one time as numerator, the other time as denominator, except for hypotenuse that appears as denominators for both sine and cos. So learn it that way. That is one way. Another way to learn this and then not to forget. Saying sine is S, sine theta S, and the ratio is opposite all over hypotenuse. And for cos, C is adjacent all over hypotenuse. And tan theta, tan T is opposite all over adjacent. And this is how we derived SOHCAHTOA. SOHCAHTOA. So this SOHCAHTOA tells the relationship of an angle with the sides of a right-angled triangle. So let's get into the business. Let's solve some questions on trigonometry and let us see how it goes. Number one says if sine theta is equal to 4 over 5. Find Roman figure 1 cos theta, Roman figure 2 tan So find tan theta. So if sine theta is equals to 4 over 5, find cos theta and sine theta. Do I get this done? If sine theta is equals to 4 over 5. So I'm going to draw a triangle to tell what this. So let's start from the solution. So if sine theta is equals to 4 over 5, that tells that if sine theta is equals to 4 over 5. So that tells that the opposite is equal to, the opposite of that triangle is equal to 4. And the hypotenuse is equals to 5. And hypotenuse and the hypotenuse is equal to 5. So if we have it like this, that opposite is equals to 4 and hypotenuse is equals to 5, then we can find the adjacent. So we need the adjacent. So how do we now get the adjacent? So let us have the diagram. So this is the diagram. We have the hypotenuse to be 5 centimeter, and we have the opposite to be centimeter. So we need this part, that is the adjacent, right? So let's name the adjacent x. So for me to get the cos theta, definitely, you know, cos theta is adjacent all over hypotenuse, and I'm not given the adjacent from the question. That means I will need to take Pythagoras theorem to find my adjacent, so that I can now calculate cos theta and tan theta. So you will need to recall that hypotenuse squared is equal to adjacent squared plus opposite squared. So adjacent squared has been said to be 5 centimeter all squared equals to, and the adjacent is now x centimeter squared plus the opposite is now 4 centimeter squared. So if I make x the sorry formula, this 4 would have to come to this side. This to be 25 centimeters squared, because 5 times 5 is 25 centimeters squared. So this become minus 4 times 4, that is 16 centimeters squared, equal to x centimeter all squared. So 25 minus 16 is simply 9 centimeters squared. So equal to x centimeter squared. So the next thing I will do is to find the square root of both sides. So the square root of both sides says that 9 becomes 3 centimeter equal to x centimeter. So x is equal to 3 centimeters. The adjacent of the triangle is equal to 3 centimeter. 3 centimeter. So now that we've gotten the adjacent, the opposite, and the hypotenuse, let's then find cos theta and tan theta. So the first thing we will state here is that our hypotenuse is equal to 5, adjacent is equal to 4, adjacent is equal to 3 centimeter, 3 centimeter, and the opposite is equal to 4. Opposite is equal to 4. Can begin to solve Roman figure 1 that says that we should find cos theta. So you will remember that cos theta is equal to adjacent all over hypotenuse. So cos theta is equal to, the adjacent is 3 all over 4, and that is our answer for cos theta, 3 over 4. So let's take the second one. I said we should find tan theta. So tan theta is equal to, we know that tan is equal to opposite all over what now? All over adjacent. So if that is the case, then tan theta is equal to 4 over 3. So we just find the ratio of other value of theta. So we now have sin theta, we have cos theta, and we have tan theta. I believe you understood everything we did in this video. See you in the next video. Bye bye.